The testing pyramid offers a structured approach to testing that makes development more efficient, cost-effective, and robust. First, let's understand what we mean by testing. Testing ensures that a program does exactly what it's supposed to. No surprises. It verifies that our app meets its requirements and behaves correctly in various situations, leading to a cleaner, more maintainable codebase. By catching bugs early, testing saves time and money, preventing costly fixes in production. It also gives developers and stakeholders confidence that the app is stable and ready for users. Think of testing as a safety check that catches unwanted behaviors before they impact users. It's an investment that makes our development process smoother and results in better, more reliable applications. The graphs highlight why writing test cases is crucial. Without tests, the risk of bugs increases exponentially as the codebase grows. With tests in place, potential issues remain manageable, ensuring better quality control and smoother project scaling. Investing time in testing helps maintain stability as your software evolves. The testing pyramid is a model that guides organizations and developers in finding the right balance of automated tests to ensure high-quality software. It helps identify which types of tests to prioritize at each stage of development, creating a reliable and efficient test suite. At the base of the pyramid, unit tests focus on testing individual components in isolation. They are quick to run and provide immediate feedback, making them perfect for catching bugs early. Integration tests come next, ensuring that different parts of the system work well together. Though fewer in number, they provide a broader scope by verifying the interactions between modules, services, databases, and APIs. At the top of the pyramid, end-to-end tests simulate real user interactions, validating that the entire application functions as expected from the user's perspective. These are the slowest and most resource-intensive, so they should be kept to a minimum, focusing on critical user flows. By balancing these types of tests, you create a more stable, reliable, and maintainable codebase. I found an interesting Venn diagram that essentially summarizes everything we've discussed so far. Pause the video and take a moment to understand all the benefits it highlights. It's a great way to visualize how the different types of tests, unit, integration, and end-to-end, work together to create a robust testing strategy. In this video, we'll dive into various testing libraries like MockK, JUnit 5, and Kotest. We'll also explore screenshot testing, compose UI testing, and learn how to measure code coverage. But before jumping into the code, it's important to understand a few key concepts about these libraries and their roles in the testing process. Let's get started. By default, Android projects come with JUnit 4 for unit testing, but you can also include JUnit 5 to take advantage of its modern features. So, what's the difference between the two? JUnit 4 is a single monolithic framework with core annotations like at test, at before, and at after. It has a class-level lifecycle, meaning setup and taildown methods run once per class. It uses basic assertions like assert equals and assert true, but it has limited support for parameterized tests and lacks native parallel test execution. On the other hand, JUnit 5 is composed of 3 modules: Jupyter for new annotations, Vintage for backward compatibility with JUnit 4, and Platform for test execution. It brings in modernized annotations like at before each and at after all, and supports per class and per method lifecycles using at test instance. With advanced assertions like assert all and assert timeout, support for parameterized tests, and built-in parallel test execution, JUnit 5 offers a more powerful and flexible testing experience. Switching to JUnit 5 can give you access to these enhanced features, making your unit testing more efficient and effective. A test double is a generic term for any kind of substitute you use in place of real objects during testing. They help simulate various parts of your code to isolate the behavior you want to test, ensuring that your tests focus on the specific logic rather than being dependent on external components. There are several types of test doubles, including mocks, stubs, fakes, dummies. While mocks are the most commonly talked about, they are just one type of test double. MockK is a powerful mocking library built specifically for Kotlin. It lets you create mocks, stubs, and spies for testing, with built-in support for coroutines, making it perfect for Kotlin's concurrency model. With annotations like at MockK, at relax MockK, and at inject MockKs, setting up tests becomes a breeze. Plus, MockK allows you to capture arguments and verify the number of calls to ensure everything behaves as expected during tests. It's a great choice for writing clean and effective tests in Kotlin. Kotest is a powerful and flexible testing framework for Kotlin that makes testing a breeze. It supports multiple testing styles, allowing you to pick the one that suits your project, whether you prefer a simple, straightforward approach or a more descriptive, behavior-driven style. Kotest also comes with a rich set of built-in assertions like should be and should throw, making tests clear and easy to read. One of Kotest's standout features is property-based testing, which automatically tests a range of generated inputs to help you discover edge cases you might have missed. It also supports tags for organizing and running specific subsets of tests, allowing you to target exactly what you need. Overall, Kotest makes testing in Kotlin both effective and enjoyable. There are various writing styles in Kotest, and we'll explore some of them as we write our test cases. However, it's important to note that while we're using different styles here for demonstration purposes, when you're working on a project or submitting your work in a professional setting, it's best to stick to a single style. Consistency in test writing makes your code base easier to read and maintain for your team. Now, let's jump into the coding part. We'll begin by updating some dependencies in our libs.toml file. First, we'll update the Kotlin version, as it's required for our screenshot testing later. Then, we'll include the necessary dependencies for MockK, JUnit 5, Turbine, and others needed for writing our test cases. You can find the updated version in the GitHub repository. The link is in the description. Next, we need to apply two plugins, one for screenshot testing and another to include JUnit 5. To keep things clean and manageable, we'll group multiple dependencies into bundles. This way, our modules can easily include the required dependencies without having to repeat them each time. To include this bundle in the module, let's open the domain modules Gradle file. First, we'll apply the plugin for testing, then include the test implementation from our dependency bundle. After that, sync the project to ensure everything is up to date. Let's start by writing our use case test. Open the email list use case file and create a new test case. Keep the file name as it is and click OK. In the next window, choose the directory for the test file. Since this is a unit test, we'll select the unit test directory in the domain module. Our email list use case has an email repository injected into its constructor. So, we'll create a private mock of the repository. This is where dependency injection comes in handy. It allows us to create mocks effortlessly, without needing to manually construct objects while writing test cases. Next, in our setup function, we'll initialize the use case and annotate the function with that before each to ensure it runs before every test. Now, let's start writing our first test case using the GWT, given when then, structure, a popular method for naming and structuring test cases. Given is where you set up your input or conditions. When is the code you're testing? Then is the expected result. This structure makes it easier to understand the purpose of each test and serves as documentation or acceptance criteria for the class or function. For our first test case, given, an IO exception is returned when the repository is invoked. Then, we should expect either left with a network error. Next, we'll write a test case for the server error scenario when an HTTP exception occurs. And finally, we'll add a test case for the success scenario, ensuring that the use case handles successful responses correctly. You can run your test cases with coverage, but by default, this might not show all the branches. This means that while you might see 100% line coverage, there could still be conditional branches or scenarios that weren't tested. To ensure you have both line and branch coverage, you can modify the run configuration and enable branch coverage. Now, when you run the test cases with coverage, you'll be able to see if all branches and conditions are properly tested, giving you a more comprehensive understanding of your test quality. Our test cases have passed successfully, and you can see how running them gives you a clear understanding of the class's responsibility just by reading the test case names. This is why writing meaningful and consistent test function names is so important. Also, if you check the class, it's marked in green, indicating 100% code coverage. This means all lines and branches have been tested thoroughly. Remember, you can customize the color settings for line coverage to match your preferences, making it easier to review coverage results. Now, let's create test cases for our email details use case using one of the writing styles from the Kotest library we included earlier. We'll start by extending our test class with shouldSpec. This style takes a lambda function as a parameter in the constructor, where we define our test cases. Alternatively, you can write the test cases in the init block instead of using the lambda function. I'll show you that later in the video. Just like our previous test, we'll begin by creating a mock for the repository and initializing the use case. For shouldSpec, we define each test with the should keyword followed by the test case name. In our earlier tests, we used the standard assert API for verification, but with Kotest, we use the should be keyword for assertions. This makes the test cases more readable, almost like natural language, which is why I prefer Kotest. Next, we'll write the remaining test cases to check for the HTTP exception and the success scenario. Finally, we'll run the test to ensure proper code coverage and take a look at how our documentation looks with the shouldSpec style in Kotest. Now, let's switch over to our data module and add the necessary plugin and dependencies for setting up unit testing. This will ensure that our data-related classes are properly covered with tests, just like the domain layer. Let's start writing our test cases for the email repository implementation class, where we'll verify if the mapper and safe API function work as expected. This time, we'll use the funspec style from Kotest to structure our tests. Instead of passing a lambda, we'll write our test cases inside the init block. First, include the mocks for our repository implementation class and create an instance of the class we want to test. In the init block, we'll use the test keyword, similar to the should keyword we used earlier, followed by the test case name. When mocking suspend functions, we'll use coEvery, which is specifically designed for mocking coroutine functions, as opposed to every. We'll continue by writing test cases for the remaining scenarios to ensure that the mapped data for our email list and email details behaves as expected. Finally, let's run our test cases and check if we have complete coverage. This will ensure that all our scenarios are properly tested and that our implementation is solid. Let's see those results. Now, let's write a test case for our extension function on throwable that we created in the error handler file. For this, we'll use the stringspec style from Kotest. With stringspec, we can directly start with the test case name and proceed to verify or assert the results without needing any additional keywords. I'll quickly write the test cases for the remaining branches of our extension function to ensure full coverage. Once the test cases are ready, we'll run them and verify that we have complete coverage for all scenarios. Now, let's move on to writing the test case for our safe API implementation function. We'll use the behavior spec style for this one. Personally, I find this style fits best with the given when-then structure, making it easy to organize and understand each part of the test. If you're enjoying the video so far, don't forget to give us a like. It helps us create more content like this, and be sure to subscribe and share the video with anyone interested in learning Android development. Alright, let's run the test cases and see if they're successful and ensure we have complete coverage. For our next test cases, we'll leverage JUnit 5 features to test our mapper class. We'll start by creating the email list mapper test class, annotate it with a test instance, and set up our app before each function to create a fresh mapper instance for each test. We'll use parameterized tests, a powerful feature of JUnit 5, along with a method source to provide input and expected output parameters. For mapper classes, using a single test case with a parameterized test is ideal. It allows us to test various scenarios easily. If we make changes to the mapper, All we need to do is update the input and output data in our method source. We'll create a companion object to store our test data and helper functions, providing actual input and output objects. It's important to avoid using mocks for such tests and instead verify the actual input and output models. We'll start by creating test data for an empty list scenario to verify that the output is also empty. Next, we'll test the filtering logic with data that includes a null ID, ensuring it handles this properly. Similarly, we'll create test data for cases where the payload is null or the from value in the payload is missing, and validate the results. Finally, we'll test with valid input data to ensure the output is as expected, covering all key scenarios. We'll also verify scenarios where some values are null, ensuring that default strings or Boolean values are correctly assigned in those cases. Lastly, we'll write test data to check if the sorting logic is working as expected, ensuring the output is in the correct order. Once all the tests are in place, let's run the test cases and check the coverage. Now, let's quickly write the test cases for the email details mapper class. We'll cover 5 scenarios in our tests. 1. Default values. Verify that default values are assigned correctly when certain fields are null. 2. Empty values. Check how the mapper handles empty values. 3. Plain text handling. Ensure that plain text is returned correctly when HTML values are empty. 4. File info values. Verify that the file info fields are mapped accurately. 5. Default file info. Check that default values are applied for file info when the input contains null values. I will skip the implementation of these functions here to keep the video short, but you can find the complete code on GitHub. Now, let's run the tests and verify the results. Next, we'll write the test cases for our view models. We'll start by adding the necessary dependencies and creating a bundle to include them in our presentation module. We'll begin by creating the email list view model test class in the unit test directory. For this, we'll use a different writing style called feature spec. Since we're testing flows, we need to annotate the test with an experimental coroutine API and set up a test dispatcher, ensuring it resets once the tests are complete. Using feature spec, we'll define each test case with the feature keyword followed by the test name. Inside the feature block, we'll use scenario blocks to structure our test code. For this test, we'll verify 2 states. 1. When the view model is first invoked, it should start in a loading state. 2. When the data becomes available, the state should change to success. To control the execution of coroutines, we'll use testscheduler.advance until idle, which runs all coroutines until the scheduler is idle. Next, we'll write a similar test to handle scenarios where an error occurs while fetching the email list. Lastly, we'll add a test case to verify the effects, specifically, that navigation to email details works correctly when an email clicked event is received. Now, let's run the test cases and check the coverage to ensure all scenarios are covered. Let's move on to creating the test cases for the email details view model using the describe spec style. We'll begin by mocking the use case and initializing the view model instance. Just like before, we'll set up the test dispatcher to control coroutine execution and then start writing our first test. Using describe spec, we'll use the describe keyword followed by the test case name. This style is similar to feature spec, allowing us to group related tests under a describe block for better organization. This time, instead of using advance until idle, we'll use await item, which serves a similar purpose for awaiting results in the coroutine flow. Let's quickly write out the remaining tests and run them to ensure everything passes and that we have good coverage. Now, let's dive into screenshot testing. Shortly, we'll also cover Compose UI testing. But it's important to note that Compose UI testing can struggle with validating certain properties like text color, padding, margins, and more. This is where screenshot testing becomes invaluable. The basic idea behind screenshot testing is simple. You capture a baseline image of the UI and then compare it with new images whenever changes are made, ensuring that nothing is visually broken. Since screenshot tests can be slow, they usually run in a separate pipeline, often scheduled to run overnight. This differs from unit tests, which are faster and typically run automatically with every pull request merged into the main or development branch. By separating them, we ensure a balance between speed and thorough visual validation. Let's start by creating the screenshot directory. To make screenshot testing easier, we need to refactor some of our code. Previously, we passed the view model directly into the email list screen, which limits our ability to use Compose Preview effectively. We'll refactor the code to pass state and effects directly into our composable screens instead of the view model. We'll apply these changes to both the email list and email detail screens. This refactoring will cause some errors in the main activity, so we'll make a few adjustments there as well. We'll initialize the view model in main activity and then pass the necessary parameters to the composables, ensuring everything compiles correctly without errors. Now, let's create the test for the email list screen inside the screenshot directory we just set up. We'll create different previews to capture screenshots for each scenario, including loading, error, and success states. This will allow us to validate that each state is rendered correctly and compare it against the baseline images. To capture the baseline screenshot, we'll run the Gradle script called update debug screenshot test. This will generate the initial screenshots that we'll use as a reference to compare against any future changes, ensuring that our UI remains consistent. Once the Gradle task is successful, the screenshots will be generated inside the build folder under Screenshot Test Results. These baseline images will serve as our reference for validating future changes. To verify that our screenshot test is working correctly, let's make a change, adjust the padding of our email item, and then run the Validate Debug Screenshot Test Gradle task. If the test fails this time, it means our screenshot test has successfully detected the change, confirming that everything is working as expected. We can similarly create test cases for our email details screen composable by adding previews. Here, we're setting up some basic screenshot previews for this screen, but feel free to enhance and expand upon them as part of your practice work. This will help you get more comfortable with screenshot testing and explore different scenarios. Next, we'll add Compose UI test cases. To do this, we'll start by creating a test class under the Android test folder. Jetpack Compose provides a set of testing APIs that allow us to find UI elements, verify their attributes, and perform user actions. Compose tests interact with the UI using semantics, which provide meaning to UI components. This semantics tree describes the UI in a way that is understandable to accessibility services and the testing framework, allowing for more effective testing and verification. We'll use the Compose test rule to write our Compose UI tests. This rule allows us to set up Compose content for testing directly. If you need access to the activity context, you can use Create Android Compose rule, which is particularly useful when testing UI elements that depend on the activity lifecycle or other Android context features. Compose offers a variety of testing APIs to interact with and verify UI components. There's a helpful Compose testing cheat sheet available on the official Android developer website, which is a great resource to familiarize yourself with these APIs. If some of the semantics you need for testing are missing from your UI components, you can manually add semantics using the modifier.semantics function. This helps make elements more accessible for testing and accessibility services. Now, let's run the tests and see if our Compose UI tests are working as expected. This will help us confirm that our UI behaves correctly and that the test can interact with the elements as intended. Similarly, I'll quickly add the Compose test for our email details screen. Remember, while setting up these tests, it's important to define content descriptions for icons and images, ensure minimum touch target sizes, and consider testing your app's accessibility. Accessibility testing ensures that your app is usable for everyone, including those using screen readers or assistive technologies, making it a crucial aspect of a well-rounded testing strategy. These aspects are crucial when writing integration tests, but they are part of a broader topic that we'll cover in a future video. Now, let's run our final test case and check the results. This will ensure that everything is working as expected and that our app is thoroughly tested. Let's see how it performs. And with that, we've reached the end of our 3-video series. We hope you enjoyed the content and found it valuable. If you did, don't forget to like the video and subscribe to our channel for more tutorials like this. Thanks for watching, and see you in the next one.